And this will be recorded, and a little later it will be on our YouTube channel and available in the archive section of our website, the link to the YouTube channel.
All right, thanks, Dan. So today we're going to talk about surfaces in Civil 3D. Now, before we get started, a couple of things. If you guys at any point during the webinar have any questions, feel free to type them in the questions. Now, I've got a lot to cover today, so we might not be able to get all the questions, but as we're going along, type in questions at the end of the webinar. I will, if we have time, I will go back through and answer the questions as they come in. So make sure you ask questions, please. It's definitely worthwhile. A couple of things I want to do first real quick. I have a couple of polls here. So what version of Civil 3D are you currently using? Are you up on Civil 3D 2013? Maybe you're not exactly sure what Civil 3D is, and you're here just to kind of see what it is. Maybe you're a late adopter and you're still on 2010 or earlier. All right, so I'm going to go ahead and close this and let's see what we got here. So looks like most people are up on 2013 now. That's great. It's good to see. 2014 is just around the corner, so we'll get to make that transition again here pretty soon.
And it's good to see that I have a companion in the what is Civil 3D area.
All right, let's real quick. What version? Do you have Infrastructure Design Suite? So this is what Stan was talking about that you're going to be migrated to here pretty soon. If you have it, most likely you have the premium version if you have Civil 3D. The standard version does not have Civil 3D. The ultimate version is the one that has Revit Structure as well as Navisworks Manage.
Yep.
So, all right, I'll go ahead and show this here real quick. So it looks like most people don't have it. So this new migration thing is a great opportunity. For an extra $55, you get a ton of software.
Yep.
I would highly recommend that you take advantage of it. Don't say, no, I don't want it. This is my personal recommendation. So, all right, and just to give me an idea of who it is I'm going to be dealing with, how would you rate your skill level in Civil 3D? Are you brand new, just checking this thing out? Do you consider yourself maybe brand new at it, intermediate, expert, or do you think you should have my job right now? Move over. You can do this presentation yourself.
Wait, who's this guy? Get out of here!
All right, looks like most people are right there in the intermediate level, so that's good. It gives me an idea of who it is I'm presenting to. Some of the stuff that I'm going to be showing today is pretty basic, but I am going to get into a little bit more intermediate advanced stuff, so hopefully everybody will be able to get everything out of here.
And 3% of you are tremendously cocky.
All right, so let's talk about surfaces in Civil 3D. So what are surfaces? Everybody knows what a surface is, right? A surface in Civil 3D. The other things we're going to talk about is some of the limitations of surfaces. What can't you do with surfaces? All right, we're going to talk just a little bit about creating surfaces. So for the few people that are brand new, this is how you create surfaces. How do you add data, and what settings should you use as you add data to the surfaces? We're going to talk about editing surfaces. I have some pretty strong opinions when it comes to editing surfaces. A surface analysis, so how do you go about analyzing your surfaces? We're going to talk about some tips and tricks depending upon the time. So let's go ahead and get right into it. So what are surfaces? So here's a pretty picture of a surface, right? Well, a surface is a tin. T-I-N. How many people know what tin is? Most of the time when I ask people what a tin is, they'll say it's a triangle something or other network. Right? Well, it's actually a triangulated irregular network. So it's a bunch of triangles. And if you really want to geek out on exactly what a tin is, it's a series of points that are connected so that a circle drawn through those 3 points don't enclose any other circles. And I put a link up here. If you can go look at the Delaney triangulation method on Wikipedia, it's got some pretty good information on it for any fellow geeks here. So I'll just leave it at that. But basically, it's a bunch of triangles. Now, let's talk about some of the limitations of surfaces. Well, it's triangles. This is a triangle. This is not a triangle. What's the difference? Well, a triangle has 3 straight lines. The figure over there on the right has arcs. Triangles can't have arcs. So if we have curved data that we need to add to a surface, we have to approximate those curves with straight line segments because it's a bunch of triangles in my surface. So that's one of the big limitations of surfaces. Let's take a look at another limitation here real quick. So what else do we have? Here's a picture. I actually took this picture near an irrigation ditch near my house. Yeah, that tree looks like it's just about ready to fall over. But if you came out here and you were doing a surface and you wanted to model this, what you'll notice is we got a bit of an overhang here. Civil 3D, or a tin, can't handle a situation like this. So every single horizontal location on a surface can only have one elevation. What that means is you can't have any overhangs or undercuts like what we see here. What we'd have to do in a situation like this is actually model 3 different surfaces. We'd have to model a surface for the top, a surface for the underbank, and then a surface again for the ground underneath. So that's what we would have to do if you really wanted to model a situation like this, is actually use 3 different surfaces. Because right through this line here, I can only have one elevation. So that's another limitation of surfaces that we need to be aware of as you're working with them. Creating surfaces. Creating surfaces is pretty straightforward. In Civil 3D, the Home tab, create design or create ground data panel, surfaces fly out, create your surfaces. Now personally, the only one I've ever used from this list is this button right here. Right? If I've got a DEM file, right, I'm going to go in and I'm going to create a surface and then add a DEM as data. Another one you might end up using is this create surface from GIS data. This one is pretty slick. If you've got a shape file that represents contours, you can actually take that shape file and add it to create a surface directly from it. Adding data to a surface. Now this is where we're going to start getting into a little bit more information here. So when you create a surface, in your prospector tab on the tool space, you expand out the surface, the definition, and down here you have all sorts of different types of data that you can add. Right? Basically the process for adding data, right click on any of these, choose add. Now as you're adding the data, you're going to get into dialog boxes such as this. So this is the Add Break Lines dialog box. And I want to get into this in a little bit more detail because I think it's kind of important. Weeding factors. Ooh, what are weeding factors? Well, basically what weeding factors do is they take out unnecessary data out of your surface, or out of the unnecessary vertices out of your break lines that you're adding to your surface. Could be used for contours as well. All right, so let me show you what I'm talking about here when it comes to this. So I've got a drawing. Let me go ahead and open up a drawing. Oh, wait. Let's try that again. Let me change my background color here. I was doing some playing around. Let's see. I'll just restore the classic colors. I'm a classic kind of guy. I like the black background. All right, so here I have a polyline. I'm going to add this to my surface as a break line. All right, so I'd go create a surface. So in the Home tab, Surfaces, create surface, give it a name, give it a style, give it a layer, all this fun stuff. As you can see in this particular drawing, this is just an AutoCAD drawing, so I don't have any styles. But what's important here is I want to add this as a break line. So I right-click on break lines, and I choose Add, and I want to weed out some unnecessary data. Maybe this break line was something that I created a feature line, and I draped it on the existing ground surface, and now I want to add this to my design surface. And so I want to weed out some of the unnecessary data. And so I'm going to toggle on weeding factors. right? And so now I have a distance and an angle listed here. So what's going on? Well, basically what happens, let me go ahead and cancel out of this. Take a look here. I've got a polyline here. It has 3 segments, 4 vertices. And what it's going to do is it's going to take a look. Is the distance from the first vertex to the third vertex less than whatever that value was? So the default value in Civil 3D is 15 feet. So is this distance less than 15 feet? All right, so what we're looking at, let me go ahead and just throw a quick dimension in here, is this distance and this distance here less than 15 feet. So you can see in this case, it most definitely is less than 15 feet. The next thing it's going to do is it's going to take a look at the angle. Is the angle less than what was listed in that dialog box? And the angle that it's looking at is the turned angle. Is this turned angle less than the value? And the default value is 4 degrees. So if I throw an angular dimension in here real quick, just so we can see this easier, you can see this most definitely in this case is greater than 4 degrees. So in this case, I meet one of the criteria. The distance between the first and the third vertex is less than 15 feet, so the data is very dense. But the angle is greater than 4 degrees, so it's very angular, so this vertex here is going to remain, is going to be added to the surface. Now let's take a look at the next vertex, this one here. So it already checked this one, so it's going to go to the next 3. What's the distance from here to here? Well, obviously that other distance was less than 15, so this one is as well. But now let's take a look at the angle. So I take a look at the angle, and it's going, as you can see, this angle in this case is less than 4 degrees. So the distance from here to here is short, so the data is very dense. The angle, turned angle here, is very small, so it's also very straight. It's dense, it's straight. This point is not going to be added to the surface. So when I come in here and I add this as a break line, and I toggle on the weeding factors here, you can see this point was not added to the surface. It was weeded out. As you can see, it did not make any changes to the actual data itself. So if I turn on my rebuild automatic here, just to make my life a little bit easier, and I make a change to this, you can see at some point it exceeds the 4 degrees, and so the point is added. Put it back so it's very straight. It is no longer within the criteria of being weeded out, so it's not added to the surface. So that's the way the weeding process works. And again, if you have any questions on this, just let me know at any time. All right, so the next thing we want to talk about when it comes to adding data is the supplementing. All right, so I can add additional points to the surface. So back here in this drawing, let me get rid of the surface. So basically what we're going to do is the opposite of the weeding. We're going to add additional data to the surface. So I shouldn't have. Let me just remove that break line here real quick. All right, and I'm going to scale this thing up by a factor of, about 100. All right, so as you can see now, let me turn my dynamic input on. All right, so you can see it's about 500 feet between them. So I'm going to supplement this data. So when I add it, I'm going to turn on the supplementing distance. And basically what it's going to do is every 100 feet, it's going to add another surface point, another point along this line. Let me go ahead and make this a little bit more angular here. And what I'm going to do is I'm going to edit this surface style so we can actually see the triangles. So as you can see, every 100 feet, if I just put in a linear dimension here, from there to there, wrong one, a line dimension, from there to there, you can see it's no distance between any two points on the surface are greater than 100 feet. And it figures out, okay, how many can I fit on here, and then it evenly spaces them. So I'm not going to end up with 2 points that are really close to each other at the end, for example. So that's what the supplementing factor does. Now, another important piece to look at, and a lot of people don't understand what this does, is the mid-ordinate distance. What on earth is the mid-ordinate distance? Well, if you've ever, you got to think way back to high school on this one, 10th grade geometry, right? So what is the mid-ordinate distance? Well, if I have, let me just draw a polyline here, and I'll make it into an arc. So I have a curve. So what is the mid-ordinate distance? Well, the mid-ordinate distance of a curve is the distance from the midpoint of the curve to the midpoint of the chord. That's the mid-ordinate distance. So if I put in a dimension here, you'll see that for this particular curve, should have changed my scale here a bit. See, it's this particular curve has a mid-ordinate distance of about 275 feet. That's what the mid-ordinate is. But what does this have to do with anything when it comes to surfaces? Well, this is what Civil 3D uses to take that curve data and approximate it as straight lines in your surface. So
Brian,
the way this works.
I will say that that's what I asked in 10th grade, and that's why I ended up in fine arts. Anyway, to continue.
All right, so basically what this does is it says, okay, let me go ahead and start at the beginning of the curve here. And Civil 3D is going to start running a line along the curve until, oh, right there, I've got a mid-ordinate distance of whatever value we set. And it's going to continue along and say, oh, right there's the next point, and right there's the next point. And so these are the points that actually ended up getting added to the surface when I have a curve. So the smaller the mid-ordinate distance is, the more data we're going to be adding to the surface. Now, a lot of things that people question about is like, okay, so the default value, if I go add data here, the default value is 1. Is that good? Is it too big? Is it too small? What should I use here? And basically what I like to tell people is, well, it depends upon the data that you've got. So I'm going to draw something that civil engineers have a tendency to draw a lot. So I'm just going to draw a polyline here. I'll throw an arc in, just throw another line off the end here. And this is curbing gutter. So here's my edge of asphalt. I'll offset that 2 feet for my flow line. I'm going to offset this 2/12 for my top face of curve. And then I'm going to offset it 4/12, 4 inches, to my back of curve. So there's my curbing gutter. So if I set up a mid-ordinate distance of 1, basically what that's saying is I'm going to draw a line from this point on my curve to this point on my curve so that I end up with a mid-ordinate distance of 1 foot. And you can see in this case, since, and obviously I didn't draw it exactly right, but in this case what happens is my flow line in my surface actually ends up going behind my back of curve. And so this mid-ordinate distance, let me pull that up again, basically says how far away from the data is it okay to create my surface. That's what this mid-ordinate distance says. And so what I like to do, whenever I'm working on a project, I think to myself, all right, what is the smallest distance I'm going to see between any 2 features? All right, in this case, it's going to be from, give me a second here, it's going to be from my flow line to my top of curve. What's that distance? 2 inches. So I like to take that smallest distance and then cut it in half. 1 inch. All right, so when I go add break lines, what I'm going to do is I'm going to use that value now for the mid-ordinate distance. 1 inch. Wait, but this is in feet. So, oh, I got to do math. Let's see, 1 inch, that's 1/12. What is that? I don't care. It's just 1 inch. So anytime you're working in a dialog box in Civil 3D and it actually displays a unit, you can type another unit. So if I go click in the description now, you can see it converts that 1 inch to 0.083 feet. Right? You can do other units as well. Oh, I want this to be 22 millimeters. Right? Oh, that's 0.07 feet. So what I found that seems to work pretty good for most projects, to set this mid-ordinate distance to 1/10 of a foot. Right? 0.08 is 1 inch, so 1/10 of a foot seems to work pretty well. All right, so when I add these now, what you'll see is that my flow line never crosses behind my top of curb. If I had done this exact same thing, let me go ahead and undo this now. And I left it at 1, you'll see my flow line crosses behind my back of curb when it goes through and does the triangulation. So whenever I'm adding in feature lines and I have a curved data, I typically use a 0.1. Now the next question is, can I change the default? Absolutely. If you go to the Settings tab on your tool space, expand out Surface and Commands, find the commands that can have a mid-ordinate distance. So the typical ones I've seen, add boundaries, add surface boundaries, add surface break lines, add surface contours. So just right-click on them. You'll have to do this for each one and edit the command settings. So let me do this for break lines, since that's one I was using. Under the Add Data options, you can change the default mid-ordinate distance to 0.1. So now when I come in here and I add break lines, it defaults to 0.1. All right. So that's adding break lines to a surface. Now the other thing I want to talk about that a lot of people have misconceptions on is adding contour data. All right, so a lot of people, contour data is some of the worst data you can get to create a surface. Right? I go out and I get this aerial data, contour data. I've got vertices every 1/4 inch on those contours, but the next contour is 400 feet away. So I have absolutely no idea what's happening between contours, but it's the worst data, but a lot of times that's the data that we get. So when you're adding contour data, right, you get the weeding factors, you get the supplementing factors. These are exactly the same as what I talked about already. You know, those aerial contours, you definitely want to weed the heck out of them, right? If you've gone in and you've digitized some USGS contours perhaps, you'll probably want to go in and supplement them. These values for the weeding and the supplementing factors seem to work pretty well, with the exception of the mid-ordinate distance. Change that to 0.1. But then down here we get into the minimize flat areas. These are the defaults: the filling gaps in contour data, swapping edges, adding points to flat triangle edges, and adding points to flat edges. Most people use these as the defaults. I disagree with it. So what should you do? Well, let's talk about these for what these do. So that very first one there, filling gaps in contour data, well, honestly, that has absolutely nothing to do with flat areas. If you've ever had a contour that somebody put a piece of text on and trimmed the contour out, right, that's a gap in contour data. So it'll just fill that in. I guess they had to put this option someplace, and they decided to put it here. But anyways, let's talk about this a little bit. So I'm sure you all have seen this when you added contour data. There we go. So over here on the left, right, you can see the this gray contour here. This is the actual polyline that I added to my surface. The resultant is this one. I get the shortcuts. So this is what happens a lot of times when people add contour data to their surface. If you go in and you minimize the flat areas, what you'll notice is my contour follows exactly along the contour. So this is what we're talking about when we're minimizing flat areas. So what on earth is going on here? Well, what happens is, hang on just a second, I'm going to change the color here, is when Civil 3D comes through and triangulates the contours, it just uses that Delaney triangulation method that we talked about, and it does it the way the program tells it to. Right? So here I've got a contour that's at a 122, up here I've got a contour that's at a 124, and what happens is these triangles connect together on the same contour. So all 3 points on this contour, or on this triangle, are on the same contour, so they're all at the same elevation, and so it's level. There is no slope to this triangle, so it's a flat area. And so this is why we have this issue. Now, what do we do about it? Well, the first thing that we can do is we can go in and have the program swap the edges. Right? This is the way older civil engineering design software worked. Land Desktop, for example. I believe Eagle Point did the same thing. And basically what this does is it says, okay, instead of triangulating this way, I want you to change, so swap the edges so that your triangles are no longer flat. And as you can see, it does a pretty good job in this area up here. So I go from an elevation of 122 up to a 124, right? And as you can see, partway through, I got an intermediary elevation. And so in this particular area, it worked really well. Basically, all it does is does a straight grade from one contour to the next contour. However, we get into some situations, like down here, where that particular routine fails. And the problem is this point can't triangulate around a corner out to this other contour. And so we end up with flat areas in here, even though we told it to minimize the flat areas. Swapping edges doesn't work here. So the other option, I like to group them into the two options, swapping edges and adding points. So the other option is to go in and tell Civil 3D to add points to the surface. And as you can see down here, it does a pretty good job. So anytime I have a flat triangle edge, it goes in and adds a point to it. And as you can see, it puts in a very small slope. Here I've got a 134 down to 133.81. So less than 2/10 foot of fall. These are 2-foot contours now, remember. And then from the 133.81, it drops all the way down to 132, which is probably pretty accurate for what's going on in this area. All right? And so in this particular area, it works really well. Unfortunately, up here, it's failed. Now looking at the contours look really good, but it still failed. What happens is it does exactly the same thing. It puts a really slight slope along those points. So as you can see from here, I've got a 124 down to a 123.61. Right? That's less than 4/10 foot of fall. And then I got 1.6 feet of fall down to the contour. So if you've ever added contour data to a surface and you run a profile and you get those stair steps, this is why. So what should you do? Should you swap the edges? Should you add points? Well, do it all. Just go in there and toggle all 4 of those options on. And so in the areas where it can swap the edges, it does. And so in this area, it works really well. Swapping edges is the ideal way of doing it. But then when in the areas where that fails, it'll then add points, and you'll end up with something along these lines. So I highly recommend that whenever you add contour data to a surface, toggle all 4 of them on. You'll just get a much better result. So if you guys have any drawings that you've added contour data to a surface before, what I would recommend is go in there and change the contour interval to, say, for example, 1/10 of a foot. So I have 1-foot contours that I added to a surface. Change it to 1/10 of a foot, and you'll see that it doesn't do quite what I expect it to do. All right, so let me demonstrate this one here real quick. So let's see. Let me just go open up. Let's see if I got a good drawing here. I've got one. Give me just a second.
And Bradford, I've got your question here, and we'll squeeze it in at the end there if we can. Probably will we have time to.
Probably, yeah. All right, so let me think that this is a good one. No, not a good one. Where's that drawing? Let's go with this one. Yeah, here we go. So in this particular drawing, I have contours. All right, these are just polylines that represent contours. And so what I'm going to do, let me go ahead and isolate these things. And I'm going to go create a surface. Actually, let me not do that. Let me do it this way instead. Let me just isolate the objects rather than isolating the layers. So if you guys aren't familiar with the isolate object tools, I highly recommend you check them out. I'm going to isolate the objects, and it left all the layers exactly the way they were, so I can go create a surface now. So I'll go create a surface. I'm going to use a 1 foot and 5 foot design style. These are 5 foot contours that we're looking at here. And that way it'll be very obvious what's going to happen. And so what I'm going to do is I'm going to add contours to the surface. I'm going to use the default settings here. All right, because, well, that's the way Civil 3D is meant for that to be. And you can see what happens is I end up with flat areas. All right, so here's my contour, and it's triangulating between these two 5 foot contours. And as you can see, this area through here is still very flat. I draw a polyline through here and do a quick profile. So this is a draw through here. What you'll notice, I get that stair-step thing going on. And that's what I want to try to avoid. So what I'm going to do is I'm going to just remove those contours. Set this to automatically rebuild. And I'm going to add them again. But this time, I'm going to toggle on all of those options. So I add my contour data. I'm going to toggle on the swapping edges. That's the only change I made. Select OK. And there it is. And you can see my profile looks much nicer. Right? My contours look a lot nicer. Then I don't have those major flat areas in here. So whenever you're dealing with contour data, just toggle it all on. All right, editing surfaces. Next thing we're going to talk about. As soon as the webinar catches up. There we go. Editing surfaces. So to edit a surface, there's several different ways of doing it. So here's our options: add line, delete line, swap edge. So I'm going to talk about these here real quick. Now, as I mentioned before, I'm kind of opinionated about this. So let me go ahead and close these drawings. And I'm going to open up another drawing. This drawing, this is just one of the tutorial drawings. And so this comes with Civil 3D. And in order to have this make a little bit more sense, I need to go edit a point style here real quick. So they kind of did things kind of odd in this drawing, but let me go turn on my points. There we go. So there's my points. So these are the Kogo points that were added to the surface. And what I'm going to do is I'm going to change my style of my surface. The way I like to edit styles of things, just double-click on them. Brings up your AutoCAD properties, and I can change the style right here in this pull down. So I'm going to change this to border and triangles and points. So I can see all the triangles. Now if I zoom in on one of these points, right, what you'll notice is I have this red X. That is the Kogo point. That was the data that was added to the surface. If I zoom in here a little bit tighter, you'll see that little square. This is the surface point. So this particular surface style is set up to display the surface points as squares. And for whatever reason, this particular point here is a bogus point. I don't want this point in my surface anymore. So what I can do is I can come in here and let me go to my surface. I can right-click on Edits and choose Delete Point. And I come in here and I grab the surface point, not the Kogo point, because maybe this point was added because of a line or a polyline or a break line or a DEM file or something along those lines. And I can delete that surface point out of the surface. It left the Kogo point alone. So basically what happens is the surface, as it builds, it says, okay, add this point to the surface, and then delete the point right there from the surface point. So that's how surface edits work. I can also do things like that around the edges. All right, so a lot of surveyors will use these types of things. So let's see, what kind of else do we got here? Let me get rid of this boundary here real quick. And let me set this to rebuild automatically. So a lot of people will do the same type of thing for boundaries. It's like, ooh, I got all these triangles in here. Let me go ahead and get rid of these triangles. So they'll come in here and delete lines. And they'll come in here and I'll delete those lines. Let's see, we'll delete those lines there. I'll delete those lines there. Come in here and delete those lines there. Let's see, we'll go delete those lines there. And you continue on around, deleting lines. All right, so they're very simple to use. Now, what I recommend, don't use them. All right, I can't stand surface edits. For example, here's that point that I deleted from the surface. This point was created because a Kogo point was added to the surface, and then I said, no, I don't want that point in the surface, so I deleted the surface point that was created from the Kogo point. Now, some engineers like to use points for design. So hopefully you will never have to do this with a survey surface like this, but maybe it's a design point. All right? You know what? This ground really shouldn't be here. It really should be up over here somewhere. So I'm just moving this point. And what happens? Well, the surface point came back. Why? Didn't we just tell it to get rid of that surface point? No, we didn't. We told it to get rid of the surface point that was right there. There is no longer a surface point there to be deleted. There is a surface point over here now, but we never told the surface to delete any point over there. All right, so this is one reason I'm not a big fan of doing these direct surface edits. Another example. When I came through here and I was deleting the surface, let me edit the style here real quick. I want my border to be a little bit more obvious, so I'm going to make it, let's see, nice yellow. Maybe I'll make it a green. And apparently, that layer is turned off in my drawing, so let me change that to layer 0. There we go. So there's my nice green border. And as you can see, what happened is when I came through here and I was deleting those triangles, I got a little aggressive, and I accidentally deleted some triangles through here, which I probably shouldn't have deleted. All right? So I want to get rid of the edits that got rid of those triangles, so I come over here to my edits, and I look down here to my list, and which edit should I get rid of? I don't know. One of those, maybe more of those. So this is another reason I'm not a big fan of surface edits. There's nothing technically wrong with them. I just personally can't stand them. I think they're difficult to manage, and I've seen people have trouble with them. Now, a great example, I had a surveyor call me up and say, hey, why does Civil 3D have holes in my surface? Civil 3D is putting holes in my surface where there shouldn't be holes. Well, what happened is he did exactly what I did with the edge. He came through and deleted triangles from the edge. And then later on decided, you know what, I need more surface. So I came over here and surveyed some more surface, added that data to the same surface, and the holes were showing up right here in this area where he went in and deleted lines. So what do you do rather than editing the point, editing the surface? Well, edit the data that's being added to the surface.
Eric, I think this is addressing your question.
All right? So I don't do edits. I edit the data that's being added. So this point, right? This point right here, 1574. 1574 is a bogus point. I don't want it in my surface anymore. So what should I do? Well, change the data so it's no longer adding it in the first place. Why is this point being added? Well, it's in the point group, existing ground points. At least I think it is. Yeah. So the existing ground points point group was added to the surface's data. So I'm going to go to my existing ground points, to the properties, and on the exclude tab, I'm going to tell it exclude this point. So I'm going to do it with numbers matching. So if you know the number, you can simply type it in. I don't know what the number is. I can't read that this is point number 1574. So I'm going to use a selection set in drawing. All right, and I go grab point 1574, and oh, hey, that was point 1574. Imagine that. So now when I hit OK, that point is no longer a part of the point group that's being added to the surface. And the nice thing is it doesn't matter where I put this. My surface isn't using this point, so it's never going to be a part of the surface. What about those edges? So let me just get rid of all these deletes that I did, because, again, I can't stand them. What do I do in this case? Let me do something here real quick. That event view is starting to annoy me. So what do I do in this case? Well, draw a polyline. It's almost as easy as just going through and deleting the triangles. I draw a polyline, and let's see, I'm going to start here. I'm going to come down here. I want to get rid of those triangles and those triangles and those triangles over there. And let's see, I want to get rid of those triangles there. And just draw a polyline and just have it cross the triangles that you want to get rid of. So I'm going to get rid of those triangles there. And we'll come over here, get rid of, let's see, let's go up to there, something like that. And let's see, it looks like about there, something like that. And maybe get rid of these triangles here. And those triangles there, and I'm done. Now simply add this to the surface as a boundary. Right-click on boundaries, choose add. I'm going to make this not a non-destructive break line. So I check that off. I guess that makes it destructive since it's not non-destructive. Right? If this had curves, you'd want to put in an appropriate mid-ordinate distance. If nothing else, at least be consistent. And I add that polyline to my surface as a boundary. And I get the same result. Oh no, I got too aggressive in this area. Not a big deal. All you have to do is edit the boundary and the points come back. Oh, I don't like this in here, so I just start editing my boundary. I don't want any of that. And my surface changes. And with the new grips on polylines, it makes this really easy to do. So that's what I like to do rather than editing surfaces. Now, one thing I do want to clarify, when it comes to edits, the edits that I'm referring to, let me change my pointer color here, are from move point up. Those are the ones that I don't ever use, and I recommend that you don't use them either. They're there. You can use them. I'm not going to tell you not to use them, but I would recommend that you don't. I just find them difficult to manage, difficult to use. These ones down here, absolutely, I'll use these all day long. smoothing surfaces, pasting surfaces, raising lower surfaces, and those are great tools. But I won't use the other ones.
All right.
All right, so that's editing surfaces. Surface analysis. So I want to come in here and do an analysis on my surface. So let me just do it to this surface. This looks like a fun surface to do it to. So basically a surface analysis is done through the properties of your surface. Now there's two things that you have to do when it comes to surface analysis. You have to have a surface, obviously, so that's not one of the things, but you need to run the analysis, and then you need to have a style that displays the results of the analysis. So I'm going to go set up to change the style here. So let's see, do we got one in here? No, I don't have one in here. So I'm going to just go create a new style. I'm going to call this one elevations. And on the display tab, I'm going to tell it to display the results of the analysis. So I'm just going to toggle on elevations here. Select OK, and you can see, ooh, the pretty blue. The different shades of blue represents the different elevations in my surface. All right? What elevations do they represent? I don't know. Let's put it in a table. So I'm going to go put it in a table. So I grab my surface, add legend. I'm going to add an elevation legend. I want it to be dynamic, so if my surface changes, the table changes. And as you can see, it's kind of boring. There's nothing in there. Where's all my data? Well, I've never actually run the analysis on the surface. So let me run the analysis. So again, I go to my surface properties, the analysis tab, and you have to hit the stupid little unlabeled white arrow right there. Yeah, Civil 3D loves the little unlabeled white arrows, huh? So I run the analysis, and now in my table, I actually have data that in there. So that's one thing to note about surface analysis. Yeah, you gotta run them before you'll see any results.
Which stands to reason, really.
Yeah. And finally, I want to throw in a few surface tips and tricks. So how are we doing on time? We got
about 5 minutes.
All right. So I'm going to throw out one. It looks like we got a question. Again, if anybody has any questions, please make sure you type them in. I'm going to throw out one really nice tip. All right, so let me change my surface style back. Again, I like to do that simply by double-clicking on the surface, changing the style. So I'm going to change it to borders and contours. Sure, why not? So this particular surface is a huge surface, right? It's a surface I created from LiDAR data, and now I want to, but I'm only working on a small piece of it. I'm only working on the pond up here. So what I'm going to do is I'm going to create what's known as a cropped surface. I grab my surface, and up there on the ribbon, under Surface Tools, I can create a cropped surface. This is a really cool tool. All right, so let me go ahead and save this. So I got to go save this someplace. So I'll just save it there. Again, I grab my surface. No, wrong button. Create cropped surface. And basically what this is going to do, this is going to create a brand new surface in a different drawing. So I can specify an existing drawing. So I want to place this in that one drawing that I already have. I can select an open drawing. I want to place it in that one drawing that I have that is open right now. Or I can create a new drawing. So in this case, I'm just going to have it create a new drawing. All right? I want to create a new drawing, so I'm going to hit the ellipsis here where it says create a new drawing. It's going to ask me which template do you want to use for this new drawing. So you grab your company template.
And if you don't have a template, we can help you with that.
You can assign the style. So I want this to have 1 foot and 5 foot design, or no, let's go with background. The layer that you want it to go onto. If you don't put a layer in here, it'll just use the default. All right. The crop area. This is the important part. Selection method. I hit the ellipsis, and it's going to ask, okay, what part of the surface do you want to use to create the new surface? And look down at your command line. I can use an object, I can do a polygon, or I can do a rectangle. In this case, I'm going to do a polygon, so I do P for polygon. I want it to create a surface that does something like that. I'm missing something here. The layer. Yes, you do have to select the layer. So I'll just put it on the C-topo QRSTUV.
Brian, was that available in the 2012 product?
Yes, this is available in 2012.
There you go, John.
So I'll just put it on C, I don't know, this layer right there. I don't know, I'm just picking one. And I'm not sure why it's not letting me, I'm missing something. Surface name, call it pond, and you can give it a description. So that's what I was missing. I was missing the name. So unless you fill all this information out, the OK isn't going to be there. So I select OK. It's going to go create that new drawing, and it just put this surface in that new drawing. And there it is. Now the nice thing about this is not a data reference. This is a surface in this drawing. I can do anything with this surface that I can with any other surface, including editing it. Now, the question really comes in, what happens if the original drawing changes? Well, do you want this surface to change or not? That's completely up to you. So what this does is this, if I go to my surface properties here, not my properties, the surface properties, under the definition, you can see it created the cropped surface, and then it created a snapshot. So if you want this surface to be unique and never change if the original surface changes, keep the snapshot in here. If you want to be able to this surface to change if the original changes, remove the snapshot. Basically what a snapshot is, it says, okay, this is the way the surface is now. The next time you go build the surface, start here and ignore everything that was before it, because this is the way it was, and you don't have to go rebuild all that information. You know, like for example, if you bring a land XML file into Civil 3D, you can create a snapshot of it and then get rid of the XML file off your system. If you don't have a snapshot, you need to keep the XML file. So that's a great thing. So there's a nice tip there for you.
And do you want to
lastly,
tackle this question here?
Does anybody have any questions?
We've got one from Bradford that's been patiently waiting since earlier in the webinar. He asks, I've noticed that if the surface, say a basin, is too dense, the contours get broken on the resulting surface, and weeding tends to fix this. The question is, are there recommended increments to weeding, as it is a bit intuitive, if that makes sense? Otherwise, please ignore the question. Thanks, Brian. And then he goes on, clarification. I used a spline to create a curved basin. So that's what I mean by dense, in that the basin is created on or into an existing surface.
Let me read here real quick. So by Bradford, if you're still around with us, by broken, do you mean the little jagged contours that people see every once in a while? I see that a lot.
And it looks like he's still here, but...
All right, Bradford.
Yes, that's
okay.
right. There we go, Bradford, yes.
So let me just erase that contour. So here I've got a polyline, and here I've got a polyline. And let's see if I can recreate this issue. So I'm going to create a surface. Yeah, that's fine. Let me make these into feature lines here real quick. Objects, never use Site 1. And I will edit these elevations. And let's say I'll make that up 5%, and this will go down up 5% that way. So I got some counterintuitive stuff. And let's see, then I will take these and I will insert some elevation points. I'm going to do an increment of, say, 5 feet. All right. And over here, I'm going to do an increment of, say, 20 feet. Let's see if this works the way I'm hoping. Yeah, so I'm assuming this is the kind of thing you're talking about, where you get the little jagged lines in here, right? Unfortunately, this is just a result of the tinning. What you want to do is you want to try to get the data to be as close to the same density as you can. So you'll need to weed some out, you'll need to be supplementing some other ones, but these are really difficult to manage. What do I do in a situation like this? Well, honestly, I draw contours a lot of times. Right? So I want to smooth this contour out. What I'll end up doing is I'll just draw a polyline. I'll snap to the contour to start with, and I'll just say, you know what, I think this polyline should do, you know, something like this. You know, and you know, I'll draw several of these, and then I'll end up adding that to my surface, either as a break line or a contour. It really doesn't matter in this case. So I'm going to add it as a contour. And you can see how it helps smooth that sort of thing out. And you just have to add a few of them in, and there you go. So that's my recommendation for dealing with situations like that.
Okay, Bradford, hopefully that helps a little bit, and we're a little bit over time, so thanks for those of you who have been able to stick in. Brian, do you have any other things you want to bring up?
Yeah, one last thing. We're online, so we're on Facebook. We're on Twitter. I have a personal Twitter account, C3D+. CAD-1 has one, CAD_1. I also have my blog. A lot of the information I talked about today is up there on my blog, so feel free to go check that out. And if you have any questions, you know, feel free to give us a shout.
That's right. And
especially if you have any questions about that migration stuff that we're, you know, Civil 3D going to the design suite. So
exactly, that's going to be an important one. We want to make sure everybody understands any implications that might come up from that. So with that, we're going to close out for the day. Thank you very much for attending today, and the recording will be on the website and the YouTube channel probably in the next week or so. So thanks very much, and we'll see you in the funny papers. Talk to you soon. Bye-bye.